Yesterday we looked at solving for x when they have the same base. So we're going to review that again today. So to start with the warm-up, we have 8 to the x equals 8 to the 57. And we know that for these to be actually equal, then x has to be 57. So we learned yesterday, if they have the same base, then the exponents are equal. So I should put it if they have the same base. The exponents are equal. So let's do a few examples similar to what we did yesterday in class. So the first one, both of these have a base of 19. Remember, the base is the big number with the exponent. So if the bases match, we can look at the exponents and we can set them equal. 4x plus 2 equals 18. Let's subtract 2 from each side. We get 4x equals 16. We'll divide each side by 4. And so here x equals 4. You can check your answer by plugging in. You could do 4 times 4 plus 2, and you should get 18. Let's try the next one. The base is hat, so it doesn't really matter what the base is. But if they're the same, set the exponents equal. So we have 2 times x minus 1 equals 14, and we're going to solve. A few different ways. We can either divide both sides by 2. Most students like to distribute, so we'll do that. We have 2x minus 2 equals 14. And then we're going to add 2 to each side. We get 2x equals 16. Divide by 2. And we get x equals 8. Again, you can check your answer by plugging in. 8 minus 1 is 7. 7 times 2 is 14. But today we're going to talk about what if they are not the same base? And the goal will be make the bases match if possible. So to do that, we have to practice finding bases that are the same. We have to be familiar with numbers and how we can rewrite them so they have the same base. So today we're going to look at base 2, base 3, and base 5. 2 can be written as 2 to the first power. 4 can be written as 2 squared. 8 can be written as 2 to the third. 16 can be written as 2 to the fourth. And 32 can be written as 2 to the fifth. For base 3, this is 3 to the first. 9 is the same as 3 squared. 27 is the same as 3 to the third. 81 can be written as 3 to the fourth. And 243 can be written as 3 to the fifth. 5 can be written as 5 to the first. We have 5 squared. 125 is 5 to the third. 625 is 5 to the fourth. So again, take a look at these numbers. If you see them, you're going to rewrite them so that they have a base and an exponent, and we'll practice that today. So for the first part of the notes, find a common base for each set of numbers and rewrite that with a common base. So let's take a look at these right here. So we have 3 and 9. So again, if we forget, we can look back at the previous page. 3 and 9 are right here. We want to write them with the same base. So this is 3 to the first power. 9 can be written as 3 to the second. How about this? This isn't up there, but we should know that 7 is the same as 7 to the first. 49 is 7 squared. And then here is 125 and 625. So this is 5 to the third power and 5 to the fourth. So here we've rewritten all these numbers so they have the same base. They have different exponents, but they have the same base. All right, let's look at the back here. We have 4 and 8, and my workspace quit, but you should have your notes, and you should be able to recognize that 4 can be written as 2 to the second power, and 8 can be written as 2 to the third power. Now remember, a common mistake I'll see is 8 cannot be written as 4 squared. This doesn't mean 4 times 2, it means 4 times 4, which would be 16, so don't make that mistake. All right, we got 4, which is 2 squared, and 16, which is 2 to the fourth. And we have 3, which is 3 to the first, and 343, which is, I believe, 3 to the fifth. Let me double check. Yep, 3 to the fifth. Okay, so here we're rewriting all these numbers so that they mean the same thing, but they have the same base. So then we take it a step further to solve. So to solve for x, find a common base, rewrite, then solve for x. So first we look at the two bases, 3 and 27. The common base is 3. So we can rewrite this as 3 to the x equals 3 to the third power. Now they have the same base, and we can set the exponents equal and solve for x. Let's try the next one. 8 can be written as 2 to the third power, but don't forget there's still that x there, and that equals 4, which can be written as 2 squared. So now they have the same base. We're going to set the exponents equal. 3x equals 2. Solve for x, so we're going to divide each side by 3. So x is 2/3. So again, your goal is rewrite so they have the same base. Then you can ignore the bases, look at just the exponents, and set them equal like we did yesterday and solve. Let's take a look at number 3. We have 9 and 3. So you find a common base, and that would be 3. This can be written as 3 squared. There's the 9. Remember, there's the x there. And that equals 3 to the x plus 12. So now we have this equation 2x equals x plus 12. Let's get the x's on one side. Let's get rid of this x here by subtracting. And we get x1x equals 12. All right, the next one, 6 and 36, that common base would be 6. So the first one will keep the same. But the second one we can write as 6 squared. And remember, we have that 2x there. So I'll put it in parentheses what we already had. And now we can look at just the exponents. We get x plus 21 equals 4x. Let's get rid of the smaller x here by subtracting x from each side. We get 21 equals 3x. We'll divide by 3. And we get x equals 7. And the last one, I'll make this one a little bit bigger here. We got 49 and 343. So we looked at the 49, we knew that was base 7. So 343 must also be base 7. So we have 7 squared. Let's try it. I'm going to try 7 to the third power, see what I get, and that works. 7 to the third power. Remember, we have some, the exponents we keep. So we have this x plus 3. Here we have this x minus 7. Now we can ignore the 7s. Let's look just at the exponents. 2 times x plus 3 equals 3 times x minus 7. And we can distribute. And we'll get 2x plus 6 equals 3x minus 21. We'll subtract 2x from each side. We get 6 equals 1x, or x minus 21. We'll add 21 to each side. So here, x equals 27. And again, you can check your answer by plugging in, and both sides should be equal. So today your goal on your assignment, you're going to first of all just practice rewriting so that they have the same base, and then you're going to try solving.